Hi, everyone. We are the College of Engineering and Applied Sciences Advancement team. I'm Sam Fitzsimmons. I was the project lead.
I'm Mohammed. I was the data collection lead.
I'm Parker. I was the lead architect.
I'm Andrew. I was the back-end lead.
I'm Marissa, and I was on the machine learning portion.
And I'm Sean, and I was also on the machine learning portion.
So just a overview of what our project was about and what the Advancement Fund as an organization stands for. They are the people responsible for gathering donations for new engineering-related developments, things like new department buildings or new classrooms. They have to gather funding, particularly from alumni, and our sponsors were the people who reach out and try to gather funding from donors. The goal of the project was to create a database off of CU's existing alumni data that gathered current online information about the donors so that we could form a predictive measure to determine a donor's likelihood and how much of a capacity of money they may be able to donate over a given period.
So the overview of everything that we've done is the heart of everything is really the predictive algorithm, which is something that we came up with to help tackle that problem of how likely is someone to donate and how much could they donate. This is all hosted inside of the website that we've created from scratch, which not only shows all of the data that we've collected from everywhere, but also the pre-existing data, and hosts it all in one easy to see form. To get all of that data from all those different sites, we had sources from everything from like LinkedIn to Glassdoor that we'd constantly scrape the internet for all of this different information that was matched up with the existing database that we were given.
All right, so the first step of data collection part was to collect data from LinkedIn and such as current job and location. So the first logical step was to look into LinkedIn API and try to get access to it. And so we did that. We applied to the API and actually waited for a few months to get a response. But unfortunately, they did not give us access. Therefore, we had to write code that could manually gather data. So the code consisted of two main steps. The first was to take advantage of web pages by extracting text and then convert that text to data in a JSON file. And here's like a single JSON file for a single person. And the second step was to automate the data collection process for every person in the database, which had almost 50,000 people. And eventually we were able to collect data for everyone. And then we used the LinkedIn data to collect data from Glassdoor, specifically salary information. And that followed the same process. And finally, we matched and combined the new data with the original database and created a new updated database that we can deal with.
So originally when we designed our project, we decided to look into a predictive regression model, which basically means that we wanted to learn the decision boundary of how much someone is able to donate. We originally looked into support vector regression, logistic regression, and AdaBoost with decision tree regressors, basically to predict how much people were able to donate. We ended up going with the AdaBoost model, and we had to tweak the model a little bit to actually predict a percentage of a person's income that they were able to donate, because we didn't have any labels to actually train our model to predict capacity. So that was our original idea, and Sean's going to elaborate more why we had to turn away from the predictive model as a whole.
Our original concept was to start out with our database that we got from CEA, and then pump that into a machine learning model and get an output that basically just told us some sort of capacity score that would like represent a candidate as a whole, like how much money they would get willing to offer and like how likely they would be to donate. But that didn't quite work because we originally thought that we'd have to update their database with newer data, but it turns out that they were missing a lot of data in the first place, and we weren't quite expecting to have to go fill in a ton of fields. So then we ended up having to pivot over to what we currently have. And what we ended with was this kind of handmade predictive algorithm that just goes into the database. It looks at every field. We like said which ones were important, like gender and job title, like where they live, and so on. And basically, it just took every one of those fields and then it assigned them a weight, which was based on similar unique values that was in the database for everything. So let's say like male. If someone was a male, then like there'd be some weight for just the male attribute of the genders, which was just set up through the Glassdoor salary data. We had salaries for every person, so we would just take like the mean salary for that one unique value across that entire field or column. And if the value was nan, then we took the mean of all the different types of values. So like we would take male, female, unspecified, whatever else there was in the database, and we would just take the mean of all those. And then we'd end up with a score between 0 and 1. The score for a given person is a sum across all the fields. And that's like, so you get like the weighted value for, like, let's say they live in San Francisco and then like they're a male and so on. You would sum up all those values and you would get a known score. And then the unknown score would be the averages of all the nan values. And then the total is a weighted combination of the known scores and the unknown scores. And then the scores are normalized to be between 0 and 1 just for readability. And the score is related to how much a person is able to donate based on their position in life. So like a low score with a low expected salary would mean that a donation is unlikely or incredibly small. A high score with a high expected salary would be a large donation is likely because they have more money and the more able to donate some of that money. And then the low score with a high expected salary would be a small donation is likely, and same with a high score and a low expected salary would be a small donation also likely, because a high score and a low expected salary means that they probably would donate, but they don't have a ton to donate. And a low score with a high expected salary would mean that they might have a lot to donate, but they probably wouldn't donate a lot of it. If we had a chance to do it all over, we would start by collecting a ton of the data that we would assume would need to be put into the database. So things that were missing, like even like where they lived or like when did they graduate or stuff like that. We try getting that from multiple sources. That would just be our data collection process. We'd put all that information in the database, and then we would be able to use a machine learning model because we'd have all the fields filled out. That would be a hard process in and of itself, but if we had started early, we probably could have achieved that goal. And then that would give us our model using regression to predict capacity.
The website itself is hosted on Heroku, which we built just a static website using HTML and JavaScript. This website does allow the sponsor to have a concise view of the data set, especially only the fields that they find important. So by clicking on certain ID numbers, you can get a specific overview of a person, but also filtering the data allows for a much more concise view of the information that you want. For profiles is the information that's displayed when you click on a person. And it's this one big page of all of their information. Finally, we also have the ability to download the entirety of the data set or a smaller filtered view of it. This is the main view of our website. We've had to reduce a couple of the fields just in order to preserve confidentiality. So in the name column, you would normally see names, but otherwise, the information is mostly here. You have everything from an ID number to their location, to their last transaction, and so on and so forth.
This is our main homepage. Down here, you click load data and it'll load in about 10 of our fields that our sponsor really wanted. Right now, we currently don't have our entire database in there due to the constraints such as confidentiality. As Andrew mentioned before, we have a profile option. Again, we're not going to be able to show you that option because of the confidentiality. But that pulls in from our entire data set of about 100 or so rows, or 100 or so different columns that display its name, zip code, major, as well as plenty other fields that the CU database would like to know. We also have about 50,000 rows in addition to this. However, it slows down our database or our website a little bit due to the constrictions of HTML. However, once it is all up and running, it is pretty easy to filter across. So you can go in here, you can filter based of ID number, name, zip code, region, lifetime giving, and it also uses regex commands. You can say greater than 200. It'll filter out all the fields that fit this. This is helpful for our sponsor because she likes to filter based on a bunch of different fields at once, and Excel isn't available for that. Once she is done filtering, she is able to download the table in any way she wants. So this would give it the table view as this, or the full data set view, which would be able to download the entire data set so that she can look through all the other fields that aren't included in this view.
So just generally what we took away from this project and the most important things that we learned can be summed up with some challenges and some successes that we encountered.
So as Mohammed mentioned before, a large portion of the project was spent manually collecting all the data because we were given an incomplete data set and we just didn't have a API key for LinkedIn. We also got our data set late. So because we got our data set late, we had to clean our data later than we wanted. And that also took some time, which in turn, we couldn't solidify a plan for our predictive model in time, which in turn made us switch over to the predictive algorithm instead of using a predictive model.
Given the current circumstances, we unfortunately had to work remotely. I mean, in general, it wasn't a very big deal, but it was a challenge at the start because we had to change the way we communicate and work together. But I mean, we still have the same weekly meetings, but we relied completely on Zoom and Slack.
Another big challenge that was kind of there from the beginning in various forms was us having to pivot the final product that we were going to be delivering and the scope. Just considering all the different changing variables on how complete the data set was and the amount of time that we had, and then the sudden switch to remote learning definitely impacted what we could and could not do. And as just adapting to those situations as they arose was the big limiting factor there.
So one of the successes that we had was even through all of the challenges that we ran into, the final product that we were able to give to our sponsor really did make her job easier and provided a lot of value to the department as a whole. It eases up on some of the time that she needs to spend filtering through a mess of data and presents the most valuable information to her all in one spot, which really is an important part of the project. And even if we weren't able to achieve all our goals, it's important to remember that what we did turn in really did have an impact on our sponsor. And last but not least, this really gave us some solid insight into what a software development project is like. We went through all the different cycles of software development and felt that we had a really good team to be agile and adapt to projects with. In the real world, scope changes all the time. You can have problems pop up that never seem to occur from the start. And we feel that our project really did a good job at navigating an otherwise really difficult time and giving us a lot of preparation for what software development projects might look like once we go into industry.
Thank you.
That needs to be included.
Yeah.